Hello, my name is Ronan and this is our construction project for Marie O'Kelly 2019 for quantity surveying year 2. This is an extension to Maloney's Garage, Killarney Road, Abbeyfield, County Limerick. It is by myself, Ronan Kate Drennan and Maeve Coffey. This is a commercial project. It's an extension onto an old existing building. It's situated on the Killarney Road, Abbeyfield, County Limerick, and it started around September 2018, and it's hoping to be completed by 2019 and early 2020. It is constructed by J&B O'Sullivan, and we thank him for giving us all the information needed to this project. So the architect was DD Drafting Solutions, and they also did the fire cert. The engineer and assigned certifier was Brendan Nolan Engineer, who's situated in Listowel. The engineer was Ronan Associates. The contractor, as I said already, was J&B O'Sullivan, and our client is Dan Maloney, who owns the existing building. So some of the construction elements that we're going to explain in our project are the substructure construction, which is pad foundations with columns and beams. There's also some substructure for the large fuel tanks that will be going in for our petrol station. Frame construction is steel frame construction. Floor construction is a precast hollow core slab with a 75mm reinforced screed, which will be on the structural steel frame as well. The roof construction is flat roof construction, and the external wall finishes is roadstone, forticrete and glazing. Roof finishes is quad core top deck single ply membrane roof panel. We have designated the roles and we have divided them up, and myself, Ronan, will do the substructure and floor construction, Maeve will do the roof construction and roof finishes, and Kate will do the frame construction and external wall finishes. So the way I'll start is to the substructure construction, pad to beam foundations. There are different types, sizes and types of pads throughout the area. This varies with the strength and stability of the soil. So the excavator comes in and digs the required depth of the width of the pads. These pads are rectangular in shape. A trench is also dug for the beams. Reinforcement is installed in the pads, and a picture of this is shown in our report. Formwork is formed around the pads and beams. Concrete is poured, settled, and the formwork is removed, leaving a concrete and beam foundation. And there's also a picture in the report for this. The pads will have a steel frame connection on them, as the frame construction is structural steel. It is vital that the steel connection and the pad is accurately constructed, otherwise it'll be wrong, and it will crack. This is the substructure construction, large fuel tanks. A large area is excavated to a great depth. A membrane is installed on the bottom of the floor. The large fuel tanks are inserted by crane, which is shown in the pictures over here to the right. When they are set by the crane and labour workers, the engineer will have an RC wall designed, and it will be constructed for safety and in case of explosion of the tank. Soil will then be inserted to compact the tank. The tanks will be set in a certain way that the fuel caps will be above the ground. Concrete will then be poured to a level the same as the capping for the fuel caps. The concrete will be left settle, and preparation will be made for the insertion of the pads and beams. This is an example of the drawing, which is for the pad foundations. As you can see that there is larger ones on the outside and smaller ones on the inside. The larger ones will be used for poorer soil, and it'll be the weight will be spread across a larger area. First floor construction. The first floor construction is linked in with steel frame structure for the building. When the steel frame structure is installed for the whole building, we can then install the floor structure. With this construction, formwork and props are needed. The floor area for this building is small, and only a section of this floor, of the first floor, is going to be covered as it is a mezzanine floor. And this is a picture of a mezzanine floor which is got from LIT's canteen. The proposed finished construction for the floor is 75mm reinforced grade on 200mm precast hollow core slabs. The columns and beams are holding up the hollow core slabs. The precast hollow core slabs will be 1200mm wide, and they will be 300mm thick with 50mm increments. I will now hand you over to Maeve for the roof construction and roof finishes. Thank you.
Hi, my name is Maeve Coffey, and today I'll be discussing the roof construction and roof finishes. So the roof construction for our project is, as you will see, as Kate will explain, it comes from the structural steel. So from the structural steel frame, when it's constructed, there is beams forming the roof. Purlins are then installed to support and give extra strength to the roof. The purlins are installed as facing pairs, so 2 are installed at a time. The section size is selected as normal from the load tables. Tube struts are used as the bracing components and installed as shown in the next diagram. The struts specified by the table above are for managing distortion due to gravity loads. If uplifts must be managed, the number of struts should be obtained from the load table. So this is the diagram of the structural steel, which you can see clearly the flat roof. So there's different elevations and section views here, which outline the different views of the flat roof construction. So then for the roof finishes, step 1 is, so the purlins are already, and the structural steel is already in place. So you apply 8mm butter rubber sealant or gun grade sealant, then the profile filler to be positioned on the wing of the gutter and sealed top and bottom with non-setting gun grade buttling sealant, and this is applicable to all panel butt ends, eaves and ridges. The first panel is laid TDY width 60mm cut, and then back up slope and fixed with a minimum of 5 number fasteners at the eaves. And you can see here in the diagram in the right hand corner that the panel is being placed. Step 2 is the profile filler is to be positioned on the ridge liner and sealed with the sealed top and bottom with non-setting gun grade sealant. So this is placed beside panel number 2. They lay the second panel, which is a DPD, and it's fixed with a minimum of 5 number fasteners to the lap and ridge. The lift membrane lap and install a minimum of 1 number fasteners at intermediate purlin positions to verge. Then apply 6mm non-setting gun grade buttling sealant to the panel side joint in line with the eaves, and this air seals as well, so their panel 1 and panel 2 are joined together. So step 3 is, so you do the same steps as the first two to all the panels along horizontally. So then you lift the membrane lap and install lap fasteners at maximum 500mm centres. The lift membrane lap and apply so you lift the lap and apply double-sided acrylic tape along the full length of the panel, which is seen in diagram 3. In diagram 4 you can then see the weld side laps with recommended hot air, so this is recommended to be done with hot air welding equipment. There is a membrane overlap of 50mm with a nominal 40mm weld. All joints should be checked for security with a probe when cool after welding, all in accordance with the relevant PVC membrane manufacturer's recommendations, and install reinforcement membrane and lap strips over the lap joints and weld with recommended hot air welding equipment, and this can be seen in the diagram number 4. So then the steps are then repeated until the whole roof is constructed. So you continue to install the next tier panel as previous steps A to M, as I have just explained. You then fix the eave PVC membrane coated metal upstand flashing through the kingspan top dock and into the liner tray at a maximum of 300mm centres, leaving a gap of 20mm between the flashing to allow for movement. Install reinforced PVC membrane lap strips to the top, bottom and butt joints of the eaves, PVC membrane coated metal upstand flashing. Weld membrane lap strips with recommended hot air welding equipment. So this is as step 4, the membrane overlap has to be 50mm minimum and a nominal of 40mm weld, and this is all in accordance with the relevant PVC membrane manufacturer recommendations. And then the fixed galvanised ridge flashing through the kingspan top dock, insulated roof panel and into the liner tray at a maximum of 400mm centres, leaving a gap of 20mm between the flashings to allow for expansion. Then you install and weld reinforced ridge membrane lap strips with recommended hot air welding equipment. And now I'll hand you over to Kate, who will discuss the structural steelwork. Thank you.
Hi, my name is Kate and I'm a QS2 student, and I'll present to you today the structural steelwork support and design and also the external wall finishes. Following on from what Maeve said about the steel frame, I will talk to you about the support and the design throughout the steelwork. So in relation to the steel frame used for this garage, it is a kingspan insulated panel. The first floor comprises with 75mm of reinforced screed on 200mm precast hollow core slabs. The safe bearing capacity of the ground is 600 kilonewtons per metre square, top of the pad footings 600mm below ground level. This allows for really strong support for the structural steel and will deficit any movement throughout the building. The deflection limits vertical and horizontal of the steel frame include beams 200 metres in length and 250 metres at the midspan, with columns at a height of 300. Also, the blockwork walls and concrete floor slabs are to assist the resisting sway in the steel structure. Here I have spoke about some of the load bearing capacities for the roof, the ceiling level and the first floor. So for the roof I have spoke about 0.75 kilonewtons per metre square, the ceiling 0.25 kilonewtons per metre square, and the roof first floor 5 kilonewtons per metre square. Firstly, I'd like to speak to you about glazing throughout the building, as it is a main external wall feature. The glazing throughout this project is a main external finish throughout the extension of this garage. The suite of the profiles has equal legs and unequal leg sections to accommodate and all anticipating framing options. Various additional profiles can be designed and incorporated, allowing architects to achieve project-specific designs. The system can be glazed both internally and externally with double and triple glazed units from 28mm to 48mm. SAT options include side hung, top hung, bottom hung, parallel openings, open in and open out configurations. Not only does TS66 Windows System offer CEN Solutions Gold Standard certificates, but it also offers Secured by Designs. Here is some images of the glazing produced throughout our project. Also, another main external finish is forcecrete. Roadstone forcecrete mandatory is a range of very high quality concrete in units, many different shapes and styles characterised by distinctive colours, textures, and when this is combined with our full range of accessories, it will enhance any building, structure or landscape project. The full range of the textures available in all colours shown, including new multicolour series. Throughout this project we use the smooth and the original and the still leader in the field. Split and rugged appearance of natural hewn stone, split fluted and split ribbed bold geometric planes create light and shade. Grooved and simulated half-space stacks, bonded appearance with structural integrity. Here are some examples of the sizes and the colours of forcicrete which can be used throughout our project. Mainly it was the red wall that was used. On behalf of myself, Ronan and Maeve, I would like to thank you for listening to our presentation here today, and I hope you thoroughly enjoyed it. Thanks.